Hello again and welcome back. Today we shall discuss about the parallel combination of cells, but it's a special case when the all cells connected in the combination are absolutely identical. Identical means they have same EMF and same internal resistance. Whatever they are made of, we don't have to go into the composition or construction. We know that EMF E and the internal resistance are same. So take this series parallel combination of two cells as we did in the last video. Okay, so this is your two cell combination. This is external resistance, its EMF V, and it is of same EMF. Internal resistance is R and its internal resistance is R again. If we have n number of cells connected in parallel combination, so what will be the effective EMF and what will be the effective internal resistance of the cell? So as we know, the cells are identical, so terminal potential between A and B will be same, right? Or equivalent EMF of the two cell as we did in the last equation, that is E equivalent is what? E1 R2 plus E2 R1 over R1 plus R2. This is what equivalent EMF of the two cell combination. Now if the cells are identical, if cells are identical, then that is E1 is replaced by E, R2 is replaced by R, and so on. And this is becoming R and R. That is twice ER over twice R. So we get EMF. So the equivalent EMF is equal to the EMF of any of the cell. Simple. So we get E equivalent is equal to EMF of any of the cell. Now for n number of cells connected, again the answer will be same. But if n cells are in parallel combination, then equivalent resistance is given by 1 over R equivalent is equals to 1 over R1, that is R. That is R plus R up to what number of terms? Suppose we have n number of cells, so we get up to n terms and they all become n over R. So 1 upon R equivalent is equal to this, and the R equivalent is equals to this, and this is what, as usual, internal resistance of any of the cell divided by the total number of cells connected in parallel combination, that is n. So this is what equivalent internal resistance of the cell. Now I can say, if I replace this combination by a single cell, my next diagram will be like this. Say if I replace this cell combination so that its equivalent EMF will E and internal resistance is equals to R over N. Internal resistance can be shown this way. So this is what the cell is now. Fine? You must be getting what I mean. That is, this is internal resistance of the combination of the cell. We don't have a single cell here. We have a large number of cells, and that has been symbolized by single one, that is E, because it is the equivalent EMF, and it is what? The internal resistance of the n number of cells. So what is the total resistance of the circuit? Now the total resistance of the circuit is, I must say this. So the total resistance of the circuit is how much? R plus R over N. This is the total resistance of the cell combination. Now current in the circuit, say this is the current, so current I is given by what? EMF over R plus, that is total resistance. Okay, this is very simple. By Ohm's law, current equal to EMF or potential difference or terminal potential over the total resistance. Fine. Now we shall raise two questions. Under what condition the current will be maximum, and under what condition should be employed to get the maximum current if we want as parallel cell combination, right? So please note this. Okay, so here it is, the current in the circuit is given by this. Case number 1, that is if external resistance of the cell is much larger than the internal resistance of the cell. Okay, then the internal resistance of the cell combination. So we shall ignore this term. That it simply implies that R over N is nearly equals to 0. So in that case, current is equals to EMF over R. Okay, wait. See, this is a kind of drawback. If we take this sort of condition, means if I had a single cell, then I would have get the same current. And if its internal resistance is very small, if I have a one cell having internal resistance very low, then the current in the circuit is given by E over R. It means, why should I take so many cells in parallel combination rather than we go for one cell? Because one cell will give the same value of current. It means this is the current due to a single cell. That is, we must write, that is current due to a single cell. So why should I take parallel combination of cells? Means why should I invest more money for the parallel combination of cells? Rather, I should be taking only one cell when this condition is applied. Mind this. Now the case 2 is just opposite of this. If R over N is much larger than the external resistance, means internal resistance of the cell combination is quite higher, much larger than the external resistance, then current, then I is equals to what? EMF of the cell, and then we shall what do? This R is approximately taken 0. So R over N, and that is N goes up and it becomes E over R. This is very important. See here. This term is the current provided by a single cell, and we have connected what? How many cells? N number of cells. So this is the current due to N number of cells. So this condition, under this condition, we get the maximum value of current. That is N multiplied by current due to a single cell. Fine. So it means this is the condition in which if external resistance is much low, then parallel combination of cell is going to give you large number of current, or in other words, to get maximum current. That is, this is the final conclusion. To get maximum current from a parallel cell combination, from a parallel cell combination, what? The external resistance R must be very small, and this is the last conclusion. So guys, this is done. You have to note all the things that if the cells are identical and n number of cells have been put in parallel combination and you want to get maximum value of current, then you take the external resistance very less. Then you can get maximum value of current, and that's it. Thank you and bye bye.